Hey, math analysis students. Today we are going to be talking about lesson 3, which is the rational root theorem in our unit on polynomial functions. All right, so let's take a look at what the rational root theorem is. So this is directly from a textbook, as you can see. You're more than welcome to read through it, but basically I'm going to give you the gist of the rational root theorem. This theorem allows us to find all of the possible rational roots. To do it, we're going to look at two things. We're going to look at our constant term, and we're going to look at our leading coefficient term. To find the roots, we end up putting all the factors of the constant term over all the factors of our leading coefficient. And that will give us all the possibilities. So translation, what I just said, we're going to call P our constant term, the factors of our constant term. And we're going to let Q be a factor of the leading coefficient. So all your P's over Q's give you all of your rational roots. So got some examples here. So you'll see the steps are typed for you there. We're going to write down the possible factors of our constant term, that's our P. We're going to write down our possible factors of our leading coefficient, that's our Q. And then we're going to figure out P over Q. So we're going to mind our P's and Q's today. So here we go. As you notice in our first example, so 1A, all right, our constant is -6. So that's my P. And my leading coefficient is 2. So the factors of -6, well, you've got plus or minus 1, meaning 1 or -1, plus or minus 2, plus or minus 3, plus or minus 6. You actually don't need to write the plus or minus for each of them. If you don't want to, you could just write 1, 2, 3, and 6. Or you could do this, where you put the plus or minus out front and then list. It doesn't matter. For 2, you've got plus or minus 1 and plus or minus 2. Sorry that moved. So now we're going to figure out P over Q. So P over Q. All right. So plus or minus. All right. And then we just want to write them over top of it. So what I normally do is I start with the 1 or whatever I've got up here, and then I make fractions. So 1 over 1 is just 1. And then 1 over 2 is 1/2. And again, I put the plus or minus outside, so I know it's actually plus or minus both of those things. Then I move on to the 2. And what I'm doing here is I'm taking this number and I'm putting it over top of this number. So the next factor would be, or the next root would be 2 over 1, which is just 2. And then 2 over 2 is actually just 1, which we've already written down, so we're not going to write it down again. Then we move on to the 3. 3 over 1 is just 3. And then we would also have 3/2. And then last but not least, we've got 6 over 1, which is 6. And then 6 over 2 reduces to 3, and we've already written that down. So those are all of my potential roots. So notice we have 6 things inside of that set of parentheses, but we double that because we have plus or minus. So really there's 12 possibilities. And we're going to figure out what we do with those on the back of this note sheet. So there's 2 other examples. Feel free to try them on your own, and then we will talk about them. I know there's like instructions that say now let's use our calculators. I'm actually going to delete that. We don't want to use our calculators right now. So go ahead and try this next example on your own, and when you're ready, you can press play. So hopefully you see there for 1B, your P was 2, your Q was 15, and here are all of your possible rational roots. So notice there are 8 things inside my parentheses, so there are 16 possible rational roots. Try one more on your own, and again, we will talk about it when you're ready. And here are the P's, Q's, and the P over Q for that 1C example. Please feel free to ask me questions about that via an email or or just asking in class in general. Uh, but notice that we ended up with 10 things inside our parentheses, so that's 20 different possible rational roots. All right, so why are we doing this? Well, we're going to figure it out. So remember, that theorem helps us to find the rational roots, first of all. And we're going to talk about one other theorem, which is the conjugate root theorem, and explains the rational roots and the complex roots. Before I explain that, let me again tell you why we're doing all of this. So basically, when I want to figure out my potential rational roots, what I can do is then try them out using synthetic division. And if I get a remainder of 0, it means that that is one of my rational roots. That means it's one of my zeros. All right, and then I can use factoring or more synthetic division to find other um, potential options there. But then we also have irrational solutions and we also have complex solutions. Just remember that everything does come in pairs. So with the rational root theorem, we always had a plus or minus. So with our conjugate root theorem, what that's just telling us is that we can have irrational roots and they always come in pairs. So a conjugate, if you remember from your good old Algebra 2 days, if you have this and this, um, they multiply and you lose that middle term, so you end up with, a squared minus b squared, a difference of squares there. But that's where the conjugate comes into play. If we want to get rid of a radical in the denominator, we multiply by the conjugate, and so the radical disappears. Same thing with the complex solutions. Um, Remember, that's when you have a negative under an even root. That's how you can get a negative, or sorry, a complex solution. All right, so knowing all this, along with Descartes' rule of signs, that's not spelled correctly. It should have the apostrophe after the S, my fault. Factoring the quadratic formula, synthetic and long division, we can find all the zeros of a polynomial function, which is what the rest of this video is going to be on. It's finding those roots. So take a moment and we're going to go through these steps here. We're going to determine our number of positive and negative zeros. We're going to make a list of those zeros. We're going to use our calculator in synthetic division to find a number that gives us a remainder of 0, and then we're going to continue until we get a degree of 2. We'll use factoring the quadratic formula, and then we're going to list all of our zeros. Whew, that's lots of stuff. So here we go. Here's our first example. And I'll do the first one full out. I'll probably do all of them full out actually. So here we go. Example 2a. So if we take a look at this example, all right, let's figure out our number of positive solutions. So this is Descartes' rule of signs, right? So we have a positive, negative, negative, positive. We change signs once and twice. So that means for our potential positive solutions, we could have 2 or 0 positive solutions. All right, for negative solutions, we have to look at f of negative x. So we're going to plug in a negative x for all of our x's. So that'll be negative x cubed. This will be negative 2x squared. This will end up being positive 11x and then positive 12. So we actually only change signs once, so that means we have one negative solution. Now we want to talk about those rational roots. That's what we did on the front of this note sheet. So I'm just going to pause the video for a moment, and you should too, and find those possible potential rational roots. All right, so as you can see, I've now listed my P's, my Q's, and my P over Q's. And so those are my potential options, right? There's actually 12 different rational roots that we could try. So what I'm going to do is I'm going to use my calculator or Desmos, and I'm literally going to type in the function as is, and I'm going to see where we cross the x-axis to get one of my zeros. So you're gonna do that right now. And if you notice, you cross the x-axis 3 times. And I'm just going to pick one of those zeros. So if you notice on your calculator, so obviously I'm not showing you on my screen right now, but I could be, x equals -3 is a solution. All right, and that is one of our potential roots that we got. So we're going to do synthetic division now. So remember our original problem. I've got 1, -2, -11, and 12. And I'm going to use -3. Now, I really could just guess and check. I could keep trying numbers and see when I get a remainder of 0, but I know that this works because it hits the x-axis. So I'm going to drop the first one down. 1 times -3 is -3. I'm going to add to get -5, multiply to get +15, add to get 4, multiply to get -12, and oh, looky there, I got 0. So that's good. So now I've got x squared minus 5x plus 4, and I'm going to factor this. This one's a nice and easy factoring, right? So I get x and x minus 4 minus 1. So then I set both of those equal to 0 to get x equals 4 and x equals 1. And we already knew x equals -3. And that is all of my real zeros. Here's the next problem. So sign changes, we've got 1, that one doesn't change, and 2. So it's going to be 2 or 0 for our positive. For our negatives, so this one would end up being negative, negative, positive, positive. So again, that's 1 negative. For our P's and Q's, you find them out and press play when you're ready. All right, so as you can see, I've listed all of my possible rational roots. It's a lot of them. 1, 1/2, 1/5, 1/10, 2, 2/5, 3, 3/5, 3/10, 4, 4/5, 6, 6/15, or that shouldn't be 6/15, that should be 6 over 10. Or it should have been 6/5. Sorry, that's actually what it should have been. I apologize there. And then 12/5 and 12. So that's a lot of different possibilities. So again, we could just try them until we got a remainder of 0, or we could plug into Desmos, which is what I've just done. So I'll show you that. So here it is plugged into Desmos, and as you can see, there's some different answers there, but oh, there's a good one, 2. So I'm going to divide by 2. I'm going to use synthetic division here. So we know x equals 2. Ooh, is one of our zeros. Sorry for that random black line there. So x equals 2 is one of our zeros. So now I'm going to write my problem again. So 10, or my coefficients, -15, and -16, and 12. All right, so let's bring down the 10. All right, we multiply to get 20. We add to get 5. We multiply to get 10. We add to get -6. We multiply to get -12. We add to get 0. Okay, so then we get 10x squared plus 5x minus 6 equals 0. Now it's a trinomial, so we could try to factor it. But I'm going to save you some time. This is not factorable. Okay, if you do like x method in grouping, you get -60x squared up here and positive 5x down here. You'd have to have opposite signs, and there are no factors of -60 that combine to get you positive 5. So this is not factorable. Well, what's another way to solve a quadratic? Your good old friend, the quadratic formula. Woo! All right, so here we go. X equals -b, so -5, plus or minus the square root of b squared, 25, minus 4 times a times c. So 4 times 10 times -6. That's going to actually become negative. Sorry, I need to do my math here. -240. And so we subtract -240. So it's going to be plus 240. And then that's over 2a. 2 times 10 is 20. All right. So 25 plus 240 is 265. 265 is divisible by 5, but it breaks down to 5 and 53, and 53 is prime. So this actually can't be reduced at all. So -5 plus or minus the square root of 265 over 20. So those are 2 of your irrational solutions there. And remember, our other one that we got earlier was x equals 2. So x equals that yuckiness, and x equals 2. So last example, so again, we want to find all the zeros. So positive solutions from Descartes, well, we only change signs, well, again, twice. So it's 2 and 0, or 2 or 0, I should say, for negative solutions. So this will be negative, negative, positive, positive, positive. Again, we just have one sign change, so it's 1. Try your P's and Q's on your own and press play when you're ready. So you'll see that I got my P's and Q's and I got my P over Q's. So we've got 8 different possibilities. So 1, 2, 4, and 8, -1, -2, -4, -8. So we could just try them out, or we could use Desmos to get us started. So I used Desmos just to get me started. And if you look at Desmos, you'll see that, poof, we crossed definitely at -2. So let's use that. And we're going to use some synthetic division here. So here we go. So we've got 1. Oh, we don't have a x to the 4th term, so we put a 0 there. 1, 2, a -12, and 8. Okay, so again, we said we're going to use -2. So drop down, 1, multiply -2, add -2, multiply 4, add, you get 5, multiply, you get -10, add, you get -8, multiply, you get 16, add, you get 4, multiply, you get -8, add, you get 0. And then what we're going to do is we're going to do synthetic again. This time we're going to use 1 because it crossed at 1. Because we still can't factor a 5-term polynomial, right? That's just not going to work out for us. So let's divide by 1. So we got 1. 1 times 1 is 1. Add, you get -1. Multiply, you get -1. Add, you get 4. Multiply, you get 4. Add, you get -4. Multiply, you get -4. And we get 0. So we've got 2 of our solutions right there, 2 of our roots. Let's see about this one. So if we have x, this will be x cubed minus x squared plus 4x minus 4. So let's see if we can factor this by grouping. So we can take out an x squared, right? And we're left with x minus 1. And we can take out a 4, and we're left with x minus 1. Cool. So set it equal to 0. So we've got x minus 1. That we factored out, and x squared plus 4 equals 0. So we know x equals 1, and then we've got this x squared plus 4 equals 0. Well, we can't factor a sum of squares, but we could solve it by the square root method. So x squared equals -4, and then you square root that. Oh no, I can't square root a negative number and get a real root. However, I can square root a negative number and get an imaginary, because the square root of -4, remember when you square root a negative, that's an I comes out, and the square root of 4 is 2. So actually it's plus or minus 2. So it's plus or minus 2i. So there's my 2 imaginary solutions. Notice I had x equals 1 2 times, and x equals -2. So there are all my solutions, because it makes sense. You have a degree of 5, you're going to have 5 solutions. You have 2 that are real, or actually 3 that are real, I guess. Just one that's a multiplicity of 2, and then 2 imaginary. So come to class with questions.